SwayamPrabha. Digital India. Educated India.
Hello, welcome back. This is lecture 29. In this lecture as well, we will be solving an example problem of shear flow in a thin wall cross section beam. So, the figure that I have drawn is a thin rectangular cross section of uniform thickness T. So, this has an uniform thickness T. So, the dimensions are given as the 4 points, the 4 corners are named as 1, 2, 3 and 4, and the dimensions are given as 10 t and 20 t. Now, we need to, there is a shear force, C is the centroid of the cross section, a shear force is applied to the cross section along y direction, but at through point 2. So, because this is a symmetric cross section, we know that the shear center is going to lie at C, at the centroid itself. So, the shear force that has been applied does not passes through the shear center. So, SC is the shear center as well, and but the shear force do not pass through the shear center, and we need to find out the shear flow in the cross section. So, the problem statement says that find the shear flow in the cross section. So, now as we have discussed earlier in the earlier lecture, we have to convert this problem into an equivalent force system problem. So, we have to take the rectangular cross section . We have to take the rectangular cross section. Let us name the point 1, 2, 3 and 4. So, this is the x axis and this is the y axis, or we do not need to draw the. So, we can convert this force to an equivalent force system, which is the force F through the shear center or the centroid, and moment which is given as 10 F, 10 T F. So, this is the equivalent force system. So, this is the centroid or the shear center of the cross section. So, as we have discussed earlier, the force which is applied at a point other than the shear center, we have converted it to an equivalent system where the force is moved to the shear center and we are having a moment which is F into 10T. The 10T is the momentum between the point of application of the force and the shear center. So, F into 10T as the moment MT that is acting on the cross section. Now, with this, let us try to find out the shear flow. So, let us assume that this is the S direction. And we have seen from our earlier expressions that Ix, so Qs minus Q0 is going to be minus F by T into Ixx into Yds. Since the Ixy is equal to 0 and Sx is equal to 0 and Sy is equal to F. So, we would only need Ixx as the sectional property that needs to be evaluated. Now, let us start solving the problem. So, for portion 1 2 or for flange 1 2, S is going to lie between 20T and 0 and Y is just going to be 5T. Therefore, my Q12S minus Q0. So, we are assuming Q0 to be Q1 to be Q0. So, let us assume this. So, therefore, we can say Q12 minus Q0 can be actually written as 5F T square by Ixx into S. Therefore, Q12S can actually be written as Q0 minus 5 F T square S by Ixx. So, this is an equation which I have to note down. So, this let me call this as A. Now, from this expression we can find out Q2, where Q2 is going to be Q0 minus 5 F T square, S is going to be 20T by Ixx, which is going to be Q0 minus 100 F T cube by Ixx. So, this is the expression for Q2. Now, for web 2 3, Y is going to vary between 10T and 0 and S is going to vary between and Y is going to be minus S plus 5T. Now, if we use this expression, we can say that Q23S minus Q2 is going to be minus Ft or I can write down the Q2 on the left hand side to cut short the step, and this is Q2 minus this. So, which is going to be, so from this expression we can get Q3 as Q2 minus Ft by Ixx minus, this is going to be 10T whole square by 2 plus 5t into 10t, which is going to cancel out. Therefore, we get Q3 to be Q2. So, therefore, let me write this. So, this is Q0, this is Q2, this is also Q2. Now, let us find out for portion 3 or for bottom flange 3, 4. For flange 3, 4, S is between 20t to 0 and y is going to be minus 5t. Therefore, Q34S minus Q3, which is actually equal to Q2, we have figured this out, and that is going to be minus Ft by Ixx into minus 5t into S, which is going to be F5F t square S by Ixx. So, therefore, Q34S is going to be Q2 plus 5F t square S. So, let me just write this down. So, Q34S is going to be Q2 minus 5F. So, this is B and this is going to be equation C. Now, apart from equation C, we can also figure out that Q4 is going to be Q2 plus 100 F t square by Ixx. Now, Q2 in turn is Q0 minus 100 F t square by Ixx plus 100 F t square by Ixx. So, this are going to get cancelled out and we will be having Q4 is going to be Q0. So, this is the other expression that we have. So, we can write that Q4 is going to be Q0, which is also acceptable physically because it is symmetric about x axis. So, Q at 1 should be equal to Q at 4. Now, let us move on to the web. Now, for web 4-1. Now, for web 4-1, S lies between 10t and 0 and y is going to be S minus 5t. When S is equal to 0, when S is equal to 0, y is equal to minus 5t, and when S is equal to 10t, y is going to be plus 5t. So, that is what we have, and then let us try to evaluate this. So, if we substitute that, then Q41S minus Q3 is minus now in turn Q4, sorry, this is Q4. So, this is Q4. So, in turn Q4 is going to be Q0, we have figured this out. So, therefore, Q41 can be written as Q0 So, this is the last equation that we got. So, this is equation D. Now, from these 4 equations, we have to evaluate Q0. So, now let us do the same thing. So, considering or since F passes through the shear center, basically this. So, Qs ds is equal to 0. Now, we have to evaluate this integral Qs ds. So, let us try to evaluate this integral. So, if we evaluate this integral, we will see that there is Q0 on all the 4 equations A, B, C, D. So, it is going to be 2 into 20t plus 2 into 10t. Then we will have minus F. So, we have from Q2 we will be having minus 100 F t cube by I x. We have a term like this in Q2. So, that into 20t plus 10t. This is the second term that we are going to have, and then we are going to have the other terms. So, the other terms are going to give us minus 5 f t square So, this is, and this has to be equal to 0. So, if we carefully see this, then this is going to cancel out with this is going to cancel out with this. So, therefore, we are left with 40 plus 20, 60 t q 0 minus 30 t into 100 f t cube by I x x, and that is equal to 0. So, this implies that q 0 is going to be 3000 f t square by 60 I x x, which gives us q 0 to be, So, if we evaluate Ixx, we will see that Ixx for this particular case is going to become, for this particular case Ixx is going to become 20. Let us evaluate Ixx. So, we haven't evaluated Ixx. So, let us evaluate Ixx. So, Ixx is going to be 2 by 12 10 t whole cube into t plus 2 into 20 t into t into 5 t. So, we can always evaluate Ixx, and therefore, this can be written as 50 f t square by Ixx. So, if we evaluate this, then we are going to get, so then we are going to get the value of, so if we substitute the value of Ixx, this is going to be 0.043 f t cube. So, this is going to be f by t. So, if we evaluate that, if we evaluate this, then we are going to get this value as Ixx is going to have a t to the power 4 term, and so we are going to get this as, so this is going to become t cube, this is going to become t cube. So, this is the solution that we are going to have. Now, this Q0 is for the applied shear force F. Now, the total shear force, total shear flow in the cross section is going to be QSS plus QTS, the total shear flow, where QSS is due to the shear force due to F passing through shear center. And QTS is due to the torsional moment MT, which was 10 T into F. So, we have figured out this portion. So, this portion we have found out. This is the portion that is left. Now, we can very easily find out the shear flow in a closed thin wall cross section due to a torsional moment M. Now, how do we find out? We will know very well that QTS is actually QT, because it will not vary with the coordinate S, can be written as MT by 2A, where MT is given as 10 into FT by 2 into A is the area 10T into 20T. So, which is going to give us QT to be 0.25 into FT. And in which direction is it going to be? It is in the direction of the torsional moment applied. So, it is going to be in this direction or clockwise direction. Now, the Qs that we have found out, was, so if you remember, we have taken S to be in this direction. This was our S direction. So, this produced a anti-clockwise direction of shear flow. So, this shear flow, it was in the anti-clockwise direction. This shear flow was in an anti-clockwise direction. So, the total shear flow Qs is going to be QSS as we have derived minus Qt. So, QSS we know, we have derived this, and Qt is going to be 0.25 Ft. So, therefore, we can find out the total value of the shear flow. So, the total value of the shear flow can actually be written as Q12S minus 0.025 F by T. So, this is F by T. So, this is F by T, which is going to be Q0, Q12 is Q0 minus 5 F T square S by Ixx minus 0.025 F by T, where this is going to be equal to 0.043 F by T minus 5 F T square S by Ixx minus 0.025 F by T. So, this is the value of total Q12S. This is the total value. So, therefore, the total shear flow in flange 1-2 is therefore given as Q12, which is Q12S, which is the Q12 that we have obtained from the shear force plus the shear flow because of the torsional moment considered in the equivalent force system. So, thank you.